Hi everyone, my name is Alex Almanza. For my project, I researched and investigated the programming language Rust. Let's get right into it. Okay, so you may remember seeing this chart from Stack Overflow at the very beginning of the semester. Here we can see the data from a survey posing the percentage of developers who are developing with the language or technology and have expressed interest in continuing to develop with it. As we see here at the top, Rust far surpasses all of the languages by a pretty wide margin. So my overall objective for this project was to investigate Rust's popularity and answer the question as to why and how the language is so beloved by the community, as well as research why a developer might choose Rust over C or C++ or Python. My methodology involved a high-level analysis of the programming language, as well as some light experimentation. Before we begin, it's important to understand a little bit about Rust's history. Rust is a fairly new language. In 2006, it was nothing more than a solo personal project by a Mozilla employee by the name of Graydon Hoare. The project picked up enough steam to get officially sponsored by Mozilla in 2009 and was publicly announced a year later in 2010. It was that very same year that the project completely shifted from its original compiler written in OCaml to the LLVM-based bootstrapping compiler, which was written in Rust. In short, Rust compiler called rustc is written in Rust. Rust can compile itself, which is pretty cool. The first stable release was made public on May 15th, 2015. So this is a really, really recent language. I was just about to graduate high school at the time. Rust has what's called a foreign function interface, which allows Rust to call routines or make use of services that are written in other languages. Historically, C++ specifically has been problematic to do this from any other language, but Rust has a library that allows calling to or from C++ with no overhead. Sadly, in August of last year, Mozilla laid off a quarter of its employees due to the COVID-19 pandemic. Among this quarter were most of the Rust team, as well as the entire Servo team, which was a browser engine entirely written in Rust. Luckily, on February 8th of this year, the Rust Foundation was founded by 5 founding companies, including Amazon Web Services, Google, Microsoft, Mozilla, of course, and Huawei. And on April 6th, 2021, just 2 weeks ago, Google announced support for Rust with its Android open source project as a C++ alternative. Rust is entirely open source. Okay, so a little bit about Rust. Rust is classified as a systems language meant for writing high-performance applications. It has been anticipated to compete with C and C++. Syntactically, Rust shares many similarities with C++. Curly braces, semicolons, pointers, all are very similar syntaxes. Rust is now being used all over the world by all kinds of companies. Mozilla, of course, Postmates, Yelp, and Dropbox were the most notable names that I found. Rust is also used in other streamlined productions as well, like web services, cryptocurrencies, operating systems, machine learning, game engines, and search engines. And so the question is posed, why use Rust? So the difference between Rust and other languages lies in a paradigm depicted in this spectrum taken from fedoramagazine.org. Rust guarantees safety in terms of memory management in a way similar to that of Python, but without the use of a garbage collector. The general design principle was to fuse the expressive and intuitive syntax of high-level languages with the control and performance of low-level languages. Rust innately doesn't permit null pointers, dangling pointers, or data races, which are things that occur when some memory operation in a thread is attempting to access a memory location at the same time that some other operation is trying to access at that same location, if that made any sense. Since Rust doesn't use a garbage collection system, it instead manages memory via a resource acquisition is initialization convention, or RAII convention. This idiom essentially dictates that resource allocation is performed during an object's creation by a constructor, and resource deallocation is performed during an object's destruction by a destructor. The reason why this is so comparatively safer as opposed to other languages like Python is that the resource allocation must succeed in order for initialization to succeed. So the resource is guaranteed to be saved in the time between allocation and deallocation. Since there's no guarantee that there will be no object leaks, there's no guarantee, or sorry, since there is a guarantee that there will be no object leaks, there is a guarantee that there are no resource or member leaks. So whereas in the scope of this paradigm, C and C++ allow for more expressiveness in programming, more freedom, it's dangerous. It's living on the edge. In Python, you do all of your programming with guardrails on, which is comforting, but also restricting. Rust sits somewhere outside of this paradigm and allows for more control and more safety. You can be expressive and not worry about writing dangerous code. So why Rust continued? According to the Rust community, there is definitely a learning curve to the language. We'll look at some code snippets in just a second, and it'll make sense. But basically, there's no small amount of dedication required to learn Rust's syntaxes. That being said, professionals, including researchers, developers, and scientists, have attested greatly on behalf of Rust's speed. Scientists working with particularly sizey datasets utilize Rust for its breakneck compile time. Rust speed can be attributed to a few things. Rust is statically typed and compiled, and therefore the compiler can optimize your code to run faster. It does not use any boxing and favors an all-encompassing stack structure. There are no discrepancies at runtime since garbage collection isn't used, and due to the stack structure, there is no overhead when data is stored. Finally, nearly all abstractions have no runtime penalties. It is much faster than Python and comparably faster than C or C++. So now we can get to the code snippets. As you can see here, we have a very simple for loop program in the languages Rust, Python, and C++. This loop will just print out the contents of a string array with a little message. If we ignore the definitions for main functions the library includes and all the unnecessary bits, we see that Python accomplishes this with 3 lines of code, and Rust and C++ about 4, but arguably 3 lines of code. Anyways, imagine the spectrum chart that we saw on the slide before last. So Rust is the middle ground between Python and C++. We can see similarities in all 3 programs. Rust it truly just looks to be a marriage between Python and C++. The primary distinguishing difference in the Rust example is here in the ampersand, in the array declaration. If we remove that ampersand, we'll actually get a runtime error. This is due to the fact that we must borrow the array. Rust has an ownership structure utilized every time we'd like to access data called the borrow checker. We want to be able to access that data without taking ownership of it. The compiler will statically guarantee that references will always point to a valid object through utilization of the borrow checker. While references to an object exist, that object cannot be destroyed. Another way to iterate without use of the ampersand would be to declare v almost exactly as appears here in the Python program, except in the for loop, instead of iterating through the range of v, we'll iterate through the range of v.iter as it appears there. Okay, here's a slightly more complex example. The function is an append function for a linked list. Here we definitely see some unfamiliar syntaxes in the Rust example. Excuse me, specifically in the parameters and the ampersand mute self and value :u32. These are much more abnormal when compared to the other 2 versions of this function. Defining a variable with mute declares that variable to be mutable, as in it can be altered or mutated. The term u32 is a reference to the class's constructor, that is the linked list class constructor, with the value being the new data entered into the linked list. What is happening here is that we are ensuring that the value will be an unsigned 32-bit integer. As for these keywords, none and some, sorry, I messed myself up. Where am I in my notes? Oh, there we are. As for these keywords, none and some, we referenced this briefly just a few minutes ago. Since we do not allow null pointers or dangling pointers, we instead specify using none and some whenever we want to check if the current object is empty. So instead of checking if the head is null, we are saying if the link has no value, create a new node with a new value. And this is just the same thing that we're doing here in the if statement in the C++ program. We're just creating a new head. As for the sum statement, we are just appending this node to the linked list if a value exists. If you're like me and you've never coded with Rust before, you might agree with me when I say that this is a little bit ugly. But as soon as you understand that this match, sum, and none sequence is very similar to an if statement, then it isn't so bad, but it's nevertheless not very beginner friendly. The beauty of Rust is not in its syntaxes, but again in its compile time, efficiency, and flexibility. Rust is extremely in favor of usability and user-friendliness in general. It just takes a little bit of getting used to. The trade-off for all these benefits is having code that will never look quite as pretty as Python, but that's okay. So the big question, why is Rust so beloved? With all that being said, from the perspective of someone who is new to Rust, this question is extremely important. How can a language that at first glance be so non-user friendly, but still insist that it actually is user friendly? Why is Rust so loved and cherished by the world's community of programmers? It actually isn't very difficult to see why. The community itself is what draws so much appeal to Rust. Due to current events, as was mentioned earlier, Mozilla laid off a majority of the Rust team. Between August of 2020 and February of 2021, Rust was maintained entirely by volunteer programmers. Since Rust is such a new language, it holds many disadvantages when compared to established languages like C++. Therefore, there are numerous projects to catch Rust up to standard. For instance, Rust is definitely qualified to serve in the gaming industry, but just suffers simply because the language is so young and doesn't have access to decades worth of libraries like C++ does. Much of the Rust community is devoted to creating these libraries from scratch, as Rust has the potential to streamline and even completely overhaul programming in future game development. It might actually be important for universities to consider including Rust in their curriculums moving forward. All Rust programmers have the de facto title of Rustation in the community. Rustations have proven themselves time and time again to be some of the most welcoming and inclusive programmers in today's industry. The human element surrounding the Rust community is very appealing, and it has shown awareness of diversity and progressiveness. Rust definitely needs to grow some more, but that's likely why it's so loved. With all its potential, Rust developers have delivered upon every promise they've made so far. The roadmap for Rust includes delivering more extensive and accessible documentation, as even the developers have commented on the same things we just addressed. Rust is not very beginner-friendly, but it can be. And thank you very much. That just about concludes my presentation. Hopefully I've inspired you to look into Rust a little bit on your own time. Thank you very much for listening.